All right, so we're going to be talking about ratio and proportion. So the first thing we want to do is define a ratio. So a ratio is a comparison of two numbers or two quantities. And a quantity is just a number that involves a unit. So something like 2 inches or 5 feet or something, anything with a unit. So ratios can be represented in different forms. For example, the ratio of 1 to 2 can be expressed as just using English 1 to 2. It can be um, used in fractional notation. So this fractional notation is the one that we're going to be using the most. So we can use all of our properties of fractions and so on when we simplify. But colon notation is another way we could write a relationship between two numbers or write a comparison of two numbers. So all of these ratios are read the ratio of 1 to 2. Now, as a side note, a rate, I'm just looking over here, a rate is a ratio of quantities with different units that cannot be converted. So if we look at this, um, the $12 compared to 1 hour, well, dollars an hour, I cannot convert to the same units. The same thing with miles to gallons. And these are rates, these are comparing these quantities with different units. And usually what we'll hear them expressed as like $12 per hour or 24.5 miles per gallon, something like that. So the next section is, or the next piece is just going to be writing ratios. And when we do write ratios, we want to make sure that we convert quantities to the same unit of measure, and then whenever possible, reduce the fraction to lowest terms. So we want to use the same unit of measure so we don't misinterpret the comparison of the numbers. All right, so this first problem here, I'm comparing 3 parts oil to 7 parts gasoline. The parts are actually the units, just the whatever you assign to it. So they're the same units. So this proportion would just be 3 to 7. Now, the next problem has different units, has 18 inches to 2 feet. So it would be wrong if we just wrote this ratio as 18 to 2. And the reason why is that the comparison of the numbers we know is different because we know there's feet is much bigger than inches. So what we need to do is convert. So we're going to convert feet to inches. Well, there's 12 inches in every foot, so 2 feet would be 24 inches. So what I'm going to do is instead compare 18 inches to 24 inches. So now the units are the same, and now we can simplify this ratio. There's a 6 factor of 6 in both, so I'm going to cancel the factor of 6, leaving a 3, and cancel the factor of 6, leaving a 4. So this ratio then would be 3 to 4, or 3/4. All right, what if we have ratios that have decimals in them, or numbers that have decimals? So again, we want to make sure we have the fraction in simplest form, and we don't need or don't have decimals in simplest form. So first of all, the ratio of 2.5 to 3.15 would look like this. Again, we don't have decimals in fractions, so we can clear decimals by just multiplying by a factor of 10. In this case, I want 2 decimal places, so if I multiply 100, that would move in the denominator the decimal place 2 places to the right. Well, when I'm dealing with fractions, I have to multiply the top and bottom both by the same number to have an equivalent fraction. So this correct ratio would be 250 over 315. So if we simplify that, there is a factor of 5 in the top and bottom, and this would simplify to 50 over 63. So the other thing we could do is use our calculator. So I'm just going to use Desmos graphing calculator. And when you go into Desmos, you'll see this, and I just use the scientific calculator. And what's nice is we can actually just put in 2.5 divided by, as a ratio, 3.15. And on the right side, you notice that it gives us a decimal place of this. But if we want to see it as a fraction, we could use this icon, convert to fraction, and it converts it to the simplified version of the fraction. So that's kind of nice. All right, going back, let's look at our second problem here, 1.68 to 4.8. So if we write this as a ratio, it'd be 1.68 over 4.8. And again, we could convert that to a fraction without decimals by multiplying top and bottom by 100. Again, I have two decimal places, so I want to multiply by 100 to move the decimal place twice. So this would be the same as a ratio of 168 over, now I need to move the decimal place two places to the right. This would be 480. And if we simplify that, let's just go back to our calculator and we'll plug in 168 divided by 480. And again, it gives us a decimal, but we can also change it to a fraction. We want that fraction. It'd be 7 over 20. So this would be the same as a ratio of 7 to 20.